Hello! Welcome to the math classroom. You're welcome back from the long break. Don't forget to subscribe, like, and share our videos. We are still discussing matrices. And so far, we've been talking about solving a set of linear equations. We have looked at different ways we could solve a linear equation. And one of the methods we are going to use today is the Gaussian Elimination method, which is a very powerful tool for computer scientists. And it's a very powerful tool as well if you are dealing with a very large data set. Then the Gaussian Elimination method is very important. For computer scientists, you could use a programming language in solving the Gaussian elimination method because of the large data sets you have. But for our lesson today, we are not dealing with so much data sets, but we are just looking at solving three unknowns. So we have three equations. So I have three equations. Then I have three unknowns. Okay, so these are the three equations I have, and each equation can be represented as a row for a matrix. So given a matrix, I could write this. So we still remember our matrix AX equal to what? B. I can represent my set of equations in this form so that each question represents what? A row. So for each question representing a row, what do I have? So my equation 1 is 1. So the coefficient is what I'm writing, minus 3 multiplied by x1, x2, and x3 to be equal to 3, 11, and minus what? 5. So you realize that if you multiply your first row by this column, you have what? The first what? Equation. And one interesting thing about the Gaussian elimination method is it doesn't really matter the arrangement of the equation. You could swap equation 1 with equation 2. The result doesn't change. I could multiply any of my equation by a constant and I still get the same what? Results. So I could add equation 1, I could multiply equation 1 by a constant and add to equation 2. Or the other way around and change the rows. It still doesn't change what? Our result. So the first thing is we try completing the matrix form. So the coefficients of equation 2, which is my second row, I have 2 minus 1 minus 1. Then I have 3, 2, and 1. Okay, very good. So I have been able to write my equation, set of equation in a matrix form. So if I want to use the Gaussian elimination method, then the first thing to do is to write the augmented matrix for that. The augmented matrix is attaching your B here, the column matrix, to the matrix A at the right. So my augmented matrix is going to be, this is going to be my augmented matrix. So I have 1, 2, minus 3. Let's attach 2, minus 1, minus 1. 3, 2, 1. Then I have 3, 11, minus 5. So this is my augmented what? Matrix. That is, I have been able to attach the column, the B part, to my matrix. So now with the augmented matrix, I could work around it. I could do anything to it. So like I previously said, you could multiply by constants and add to another row, or you could add 2 rows. So what we want to achieve here is the purpose of the augmented matrix is to form an upper triangular matrix from the augmented matrix, so that we could find the 3 unknowns. That's our x1, x2, and x3. So how do we go about it? So what we want to do is, so with this matrix, we want to form an upper triangular matrix. So let's say this is our upper triangular matrix. Okay, so with our upper triangular matrix, this is what we call the pivots. That is a principal pivots. So what we want to achieve is to eliminate all the numbers under the principal pivots. So I want to make all the numbers under this principal pivot to be equal to what? 0. So you realize that, let me write out, I'm going to clean this side, so I'm going to write out this very well so that we use it 1, 2, 3, 2, minus 1, 3, 2, 1. I have 3, 11, then minus 5. Okay, so let me clean this and let's use this to solve. So the aim is what? This is my principal what? The pivots. I want to eliminate all the numbers under the principal pivots. So I'm going to make this 0 and that's what? 0 as well. So what can I do? You realize that I can multiply. So let's say this is row 1, row 2, then row 3. You realize that I can multiply row 1 by 2. So 2 times row 1. If you multiply, what do you get? You realize that you have 2, 4, 3, 2, 4, 6 times 2, 6. Okay, so this is what I have. Then I can subtract the result from row what? Row 2. I can subtract the result from row 2. So I have row 2 minus 2, 4, 6, 6. If you subtract, what do you get? You realize that you are going to have what? If you subtract 2 minus, so I have 0. Okay, then the next number is going to be what? Minus 5, 5, then what? 5. So then, our new matrix, then, this becomes what? Our new row what? 2. So now, my matrix becomes what? Now, this is how my matrix will look like. 1, 2, 3, 3. I have 0, minus 5, 5 and 5. Then I have what? 3, 2, 1, then minus what? 5. This is what I have now. So you realize that we have eliminated the number here. So we do the same thing for this. So what do you think? Now let's multiply row 1. So this is still row 1. This is still our new row 2. This is still row what? 3. So we multiply row 1 by 3. 3 times row 1 is going to be what? 3, 6, 9, and what? 9. So I have 3, 6, 9, minus 9. Okay, so it was minus. So I have minus here. My equation was minus. The equation I have was minus 3 here. So minus 3. Let's not forget minus 3. Okay. So if I had it right, then so it means that this is going to be what? Minus. That was the equation I had. Okay. So it means I have minus here. Okay, good. So from this, then we can subtract from equation what? 3. So I have equation 3 minus 3, 6 minus 9, 9. Then what will be our results? Do the subtraction and let's see. We are going to get 0 minus 4, 10. What will be the last result? Minus what? 14. This is what? Our new what? Row 3. So this is what we have. So our new matrix is going to be what? 1, 2, minus 3, 3. I have what? 0, minus 5, 5, 5. Then our new row 3 is what? 0, 0, minus 4, 10. Then minus what? 14. So we still have row 1. This is our new row 2. This is our new row what? 3. So we are done with what? The principal pivot. So our second pivot is this. So we'll try to eliminate the number under our second pivot, which is what? The negative 5. To get what? 0 here as well. So what do? You realize that we can multiply 4 divided by 5 by our new second row. 4 divided by 5. So if I say 4 divided by 5, you realize that it is what? It is A what? A32 minus A22, which is minus 4 over minus 5, which is what? 4 over what? 5. Very good. So if I do that, so I have 4 over 5, so I can multiply 4 over 5 times my new row 2. My new row 2, which is 4 over 5 times my new row 2 is what? 0 minus 5, 5, and then what? 5. If I multiply, what do I get? You realize that I get 0 minus 4, 4, and what? 4. Now, I can subtract this from my new row 3. So let's say my new row 3 minus 0 minus 4, 4, and 4. If you do the subtraction, what are you left with? We have 0, 0, 6, and what? What do you have? Minus what? 18. Okay. So now this becomes what? The row 3 here. So I've tried eliminating that. So I can write my new matrix as, so what do I have? I have 1, 2, negative 3. I have 3, 0, 5, minus 5 here, 5 and 5. Then I have 0, 0, 6, and minus what? 18. So what do you realize? You realize that I've been able to form what? My upper triangular what? Matrix. So this is the upper triangular matrix I was talking about. So with this upper triangular matrix, I can then find my 3 unknowns. That's x1, x2, and what? x3. So let's look at, now let's write it, let's detach the last part from the matrix and write the original. So what do I have? If I detach, you realize that I have 1, 2, 3, minus 3. Don't forget. I seem forgetting 3. Then I have 0 minus 5, 5 and 5. Then I have 0, 6, 0, 0, 6. Then minus what? 18. Okay. So then let me write it. The initial thing. So I have x1, x2, and x3. Very good. It's going to be equal to what? Now let's write 3, 5, and minus what? 18. Good. So we have been able to write it in the form of what? Ax to be equal to what? B. Now we can find the place of what? X1, X2, and X3 using the method of what? Back substitution. Back substitution. So we solve from the back. So you realize that when you multiply, you have what? 6x3 to be equal to minus what? 18. If you solve, your x3 is going to give you what? Minus what? 3. If you take your second row, what do I have? I have multiply, you have minus 5x squared plus 5x3 to be equal to what? 5. The interesting thing here is we know the value of what? X3. So what do? We can do substitution for that. So you realize that from here I have minus 5x2 to be equal to what? This is minus, let me write 5 minus 3 equal to what? 5. If you try solving, you have what? It's minus 5x squared to be equal to 5 plus 50, which is what? 20. So you realize that your x2 is going to be equal to what? Minus what? 4. Then let's write for equation, for the first row, equation 1. For equation 1, what do we have? We have, for equation 1, you realize that I have 1x1, which is still x1, plus 2x2 minus 3x3 to be equal to 3. You know the values of what? X2 and what? X3. So you do the substitution. Pause the video and let's see what you get. Okay. So you realize that I have what? X1 plus, what is X2? X2 is negative what? 4 times 2 is going to be what? Minus what? 8. Then x3 is what? Negative 3 times negative 3. That is going to be what? Plus 9 to be equal to what? 3. If it's solved, you are going to have x1 to be equal to what? This is going to give us 1. This and that is what? 1. So minus 1 here is going to be towards 2. So x2 is going to be what? 2. So therefore we can then conclude and say that the values of, so I have x1, x2 and x3 is going to be equal to what? 2. X2 is minus 4 and minus what? 3. Very good. So we have been able to find the values of what? X1, X2 and X3. That is the Gaussian elimination method. Don't forget to subscribe. Thank you.